All right, for this week we are working on vectors. So vectors have two components. They have both a direction and a magnitude. Motions in one direction along a line give their direction in terms of positive or negative. So we've used simple vectors ever since pre-algebra when we look at integers, which are just positive and negative whole numbers. So examples such as negative or positive 4, plus positive 4 equals positive 8. Add those two vectors together and you get a bigger vector. If you have positive 3 plus negative 3, those are the same size, so that ends up equaling 0. You could also show that by doing up and down, where we've got up 4 plus down 1 equals up 3. So vectors oftentimes move in two dimensions, either over, which is left and right, and the up dimension, which is up or down. This will take place on a two-dimensional plane, just fancy speak for like a coordinate graph or a coordinate plane that we've always used. So magnitude is the distance of the vector, and uh, the direction is just where we headed. So if you think about like you're going to the library and it's 7 or 5 blocks this way, which would be to the east. Never eat soggy waffles. So 5 miles to the east and then 5 miles to the north. There's the library, here's your home. But then you're friends with Superman, I don't know. And Superman wants to meet you there from your home. And so he asks you, hey, how do I get there? Well, he doesn't need to follow that 5 by 5 because he can just fly straight there. So that black line for Superman is a vector. It has a magnitude, how long is it, and it also has a direction. So the magnitude here would be just how long is this, which is using Pythagorean theorem. 5 squared plus 5 squared equals s squared. I should have picked better numbers. We get 50 equals s squared. So s equals square root of 50, which is roughly like 7.1 or 7 blocks. Where this was blocks on the map or in the city blocks. Okay. If you think back to your special right triangles, which hopefully you learned in geometry, we covered it again next year in pre-calculus, but you might also then notice that this is a special right triangle where these two sides are equal or they're congruent, so it's a 45, 45, 90 triangle, which means this angle here is 45 degrees. So the direction for Superman is 45 degrees and he travels for 7.07 blocks. We'll often refer to this angle as theta. That is our variable that we use for angles most of the time, just another Greek letter. So then sometimes we'll do where we add the two vectors together like we did for Superman. That's called the resultant vector. The resultant vector is where do you end up when you do more than one turn. So if we look at this triangle here, where this vector is 4, the x vector is 3, and then, or components, and then the resultant here would be 4 squared plus 3 squared equals x squared. 25 equals x squared. Take the square root of both sides. We get x equals plus or minus 5, but here we know it's positive because this and this are both positive. So x equals 5. This angle is going to be a little bit bigger than 45 degrees. We could estimate it to be 50 degrees, somewhere between 50 and 55 degrees, the angle theta here. In a few slides, we'll talk about how to calculate that using trigonometry. But for now, we can just kind of estimate it's roughly 50, 55 degrees, somewhere in there. For example 4, just one more example here of this. We're going, the x component is 6, the y component is 3, and so we want to find the resultant vector. That would be 6 squared plus 3 squared equals v squared, 36 plus 9 equals v squared, 45 equals v squared. So we take the square root of both sides. It's positive again because both the x and y are positive, so v is roughly 6.7, 6 and 7 tenths. So remember, that's how long the vector is, how far we go. If we know the resultant vector, which is 10, and we know one of the components, here we know what the y is, so then we want to find what is the x component. We can still do Pythagorean theorem. X squared plus 5 squared equals 10 squared. X squared plus 25 equals 100. X squared equals 75. Take the square root of both sides. X equals, this time we're going to leave it as a reduced radical, 5 square root 3. So if you need a refresher on that, 75 can be rewritten as 25 times 3. So square root of 25 times square root of 3 is 5 square root of 3. This is also a special right triangle. It's our 30, 60, 90s. So how we know that, when you go from the short leg, this is the short leg to the long leg, multiply by 2. When you go from the short leg to the long leg, or short leg to the hypotenuse, was times 2. Now it's short leg to the long leg, we multiply by square root 3, which means this would be 30 degrees. So this is a little bit of review from geometry as well, but if you don't learn geometry, here's a quick rundown on it. So trig ratios is all based off of a right triangle. There's more in depth here, which you can go find a million videos on YouTube explaining why trig ratios work. I'm not going to spend the time here, but if you want to learn that, you can. And then we have what we call a reference angle, which is one of the angles that is not the right angle. It could either be this one or the other one. We'll mark it as theta. So if this is theta, then we've got 3 different sides that we can label. The side that's opposite the right angle is always the hypotenuse. The side that touches the angle is called the adjacent. And then the side that's opposite, that doesn't touch the angle. So theta is always, our reference angle is always between the adjacent side and the hypotenuse side. The adjacent side and hypotenuse always make our theta angle. So if we switched it, which I'll show here in a second, these two sides would change. But for now, with these labels, now we can do our trig functions, which is sine, cosine, tangent. You'll see them on your scientific calculator. Sine of theta equals the opposite side length over the hypotenuse side length. Cosine of theta is adjacent over hypotenuse. Tangent is opposite over adjacent. Oftentimes, how we'll help kids try to remember this is a little uh, mnemonic device. I don't remember what it's called. SOHCAHTOA, where the first letter is representing your trig function. The next letter, O, A, and O, is representing the first letter of the numerator. And then the last letter is representing the denominator. So whenever I did trig, I would always write this at the top of my paper so I had a quick reference to help me figure out which trig function I'm using. So, remembering that now, if we have this triangle here, where this will be theta, this one we'll call alpha, and then we've got our right angle 3, 4, 5. So if we're doing sine of theta, well, for sine of theta, let's actually do it a different color so we can keep track of what's going on here. Let's do it in red. Sine of theta, like we just talked about, SOHCAHTOA. Sine is opposite over adjacent. So if we're looking here, this would be our opposite. This is our adjacent. This is our hypotenuse. So sine of theta would be 3 over 5. Cosine of theta, which is adjacent over hypotenuse, is 4 over 5. And then tangent of theta is 3 over 4. We switch sides. Now we're looking at our alpha. That means this now is our opposite, and this is our adjacent, because this angle here is between the adjacent and the hypotenuse. Hypotenuse doesn't change. It's only the opposite of adjacent. So we do sine of theta, or sine of alpha, sorry. That's 4 over 5. Cosine of alpha is 3 over 5. And tangent of alpha is 4 over 3. So then inverse trig is just if we have sine of theta equals opposite over adjacent. What we can do when we're trying to solve for a missing angle, let's say we've got this example here where this is our theta, right angle. We know that this is 4 and this is 5, but we don't know the angle. So our setup here is sine of theta equals 4 over 5. Now we're solving, this is a one-step equation. If we had, back in the day, pre-algebra, before that, 2x equals 4, we would divide this by 2 because dividing is the opposite or the inverse of multiplying. Adding and subtracting are inverses of each other. Squaring and square root are inverses of each other. So for trig, we have an inverse and it's just sine inverse. -1, or an exponent of -1 means inverse. So we're taking the inverse of sine here, inverse of sine here. On your calculator, you're going to want to find how to do that. Usually you have to press like the second button or some type of button to make it where you do the option right above a button. But I can help you with that if you get stuck. So theta, or inverse theta here, would then be, oh, I gotta find my calculator. There's my calculator. (53.1 degrees). And since we know that the three angles of a triangle add up to 180, one of them is 90, that means the other angle here, alpha, is just 90 minus 53.1, which would be 36 and 9/10 degrees. All right, so now we're going to put all this together. We're going to have, there's our vector, 7.2. And then we're going to be given all three parts here. Our y component is 6. Our x component is 4. Really, it's -4, but for now, we're not going to be too worried about left and right. So because this is a right triangle, we can then do any one of our trig functions to figure out what this angle might be. So let's do tangent of theta equals 6/4. Take the inverse tangent of both sides. And we get theta equals 56.3 degrees. But what doesn't make sense about that is when we're doing these vectors, we've not been too clear on this yet, we always go off of the positive x-axis. So the angle we're looking for is actually this angle here for the vector. This is the real angle we want. So to get alpha, that's going to be 180 degrees minus theta. Because 180 degrees is this here. That would be a measure of 180 degrees, a straight line. We subtract out theta here, and that leaves us with alpha. So 180 minus 56.3 degrees gets us roughly 123.7 degrees. So the last example here, we're going to be doing 3 vectors. So we've got one vector plus another vector plus a third vector. This is 1, 6, 3. So really what we can do is we can rewrite this. We can move these vectors around. So what it becomes is 3, 1, 6. Add those together, that's just 4. So our new triangle is 4 by 6. So we'll have 4 squared plus 6 squared equals v squared to find our vector. 16 plus 36 equals v squared. 52 equals v squared. V equals 7 2/10. And if we want to find the angle, so the angle would be here for theta. So it'll be tangent of theta equals 6/4. One thing I always recommend is use the numbers that have been given to you. Don't use numbers that you have calculated if at all possible, because if we accidentally did something wrong with this and then use that in our trig function then would be wrong as well. But if we did something wrong for our vector calculation, we still have a chance to get our angle right because we're using the numbers that were given to us. This was probably the one we just did. Yeah, 56.3 degrees.